All right, welcome everyone. Just a quick heads up. These will be technical. It's a workshop after all. I will start with a sort of introduction to the things we'll be talking about. Oops. And might be a bit boring at first, but then halfway through the workshop, if you have laptops and you want to try it out, there will be exercises. The first ones, I'll just do them with you, and the end of the workshop will be do it yourself kind of 20-30 minutes time slot. If you don't have laptops, what we can do during that time is I can either do something with you or you can ask questions in the meantime. But for the time being, if you are planning on doing the exercises and following along as well, there is this repo here, you can just clone it, that has all the different modules, all the different exercises, including the ones that I will let you guys do by yourselves at the very end. So I will show this again right before we start the technical part. So if you want to do it now, otherwise I'll just move on. So, oh, sorry, are you still doing it? You got it? Okay. Right. So I don't know if you've ever heard about Pebble, rocks, craft tools. I'll explain all of that. That's the first part. Try not to fall asleep. So I'm on the left side. My name is Cristovao, just Chris, because it's too hard to do the whole thing. I have Sergio here with me taking pictures. He's the master of the craft tools. So anything craft related, he can help you. But we also have Rafi, but he's not here today. Unfortunately, he couldn't make it. But if you wanna reach out to him on social media or something, he can also help you with questions about the workshop. So just before we start, just for me to get a feel of the different levels around the room, if people have used these or not, just tell me, does anyone know what a rock is? Right, a few people, that's fine, okay. Has anyone ever used a craft tool? Charmcraft, Snapcraft, Rockcraft? Okay, that's perfect. So I think, well, this question is kind of, if for those who know what a rock is, have you ever used Rockcraft and built a rock? All right. Okay, cool. So we have a few people that have used craft tools. That's the most important thing because the exercise will be based on Rockcraft. So if you know one craft tool, it's very likely that you'll get used to the new craft tool. But if you have never used it, I have a few examples that are quite simple to get you started. So before we get there, just to put some definitions on the table, a rock. So a rock is not a thing per se. It can be confusing if you start talking about it as if it was its own kind of artifact, but in reality, it's just a container image. Okay, a rock is an OCI compliant container image. And if you don't know what OCI is, OCI stands for Open Container Initiative. And this is a group of people that includes some of the major players in the container world that have put together specifications for the different components that are involved in container management, from runtimes to registries to images. And those specifications dictate what the container should look like and how it should be handled. From our case, a rock is a container image that abides by the specification of the OCI images. So this is why they are portable, right? If you think about it, if anyone was doing their own design of a container, there would be no assurance that it will run on different systems, different computers, and different tools, like from Docker to Podman and so on. So OCI compliant, that's the ground basis. All rocks are container images that are OCI compliant, very much like any other Docker image out there. But they have a very specific set of opinionated design decisions. So first, all rocks are Ubuntu LTS based. No question about it. So if you have a rock, it's Ubuntu LTS based. No interim releases, no other distros, it's Ubuntu LTS. And then there's a set of design choices that are very opinionated, built on top of the OCI specification. I'll show you a few more of those later on. Say again? Yeah, I can do that. So the first question you might ask is, why should we use rock if they are just like any other container image? Now, there was a cool survey done some time ago where we were asking people, what do you think about when you are about to pull a Docker image, container image from Docker Hub, VCR, ACR, whatever you pull images from? So I kind of given you the answers from other people. I don't know about you guys, but a very frequent answer I hear from people is that, oh, I'll just go to Docker Hub and I'll pick whatever it's official. If it is official, it has the official stamp, I'll just trust it, right? But the survey shows something a bit more interesting, that people actually care about certain details that sometimes are not that visible or make explicit to the user. And the first one was security, which kind of, when you talk about it, it just sounds obvious, right? You don't want to pull an image, deploy it on your production environment that carries CVEs with it, making your whole infrastructure vulnerable, right? So it's just obvious. So the security part is the one that we'll be talking about the most, and it's probably one of the main drivers for Rocks to exist, but there are other things. So what sets Rocks apart from other container images is its design. So it starts with an entry point. All Rocks have the same entry point. It's an init process that we have built at Canonical, and all Rocks start with it. So if you want to put your application in a container, in a Rock, that init process will launch your application. Your application will not be the entry point per se. It will be executed by our entry point. And then there's built-in metadata. But I'll give you an example of something that I've struggled with in the past, and I think it's just silly that not everyone is doing this. I had an application that for some reason, I think it was because the application was designed to run on different base images, Alpine or Ubuntu, Debian. I wanted my application to dynamically, at runtime, get the name of the image where it was running on. At runtime, how do you do that? Such a simple thing. It's so silly that you cannot do that. You need to bind the Docker socket into the container image to your application to use the Docker client to ask Docker what. It's a mess, right? So images should be self-sufficient. You should have enough information inside your images that allow your application to infer information about the environment where it's running, right? The second part is that it's all declarative. You want to make this experience super easy. So YAML files, for example, instead of being imperative, you don't need to write scripts. You don't need to be text savvy to build a container image. They should be accessible. They are a commodity nowadays. And it's Ubuntu. And then it's the security by design. So trying to go back to that survey, because we use Ubuntu LTS, you are guaranteed that when you build a Rock, you always get the latest and greatest because Ubuntu is refreshed very often. There are SLAs, there are support commitments that guarantee that if there's a patch, CD patch, or there's a new update to a certain package, we'll get new container images for Ubuntu released within hours, right? So Rocks take that and use it to its benefit. Now, this might be a bit too kind of in detail for this workshop. You don't really need to know all of this. But for those who are curious, I'll just skim through it. This is the overall design of a Rock. And it's mapped to the OCI layout. So the OCI specification for an image says that you must have a bunch of files. And by the way, if you don't know, a container image is just a tarball of tarballs. Like, if you ever thought about it, what is a container image? It's a tarball. Right, if you try to unpack it, it's just a tarball that has a few JSON files, and then your layers, where the application is, it's just tarballs as well. Right. So that's what we can see here. There are two image index, OCI layout, an image manifest, image configuration. That's all JSON files. And then you have the layers, where your code is, where your application and packages are. And those are tarballs. And in our case, for Rocks, what we make sure of is that the first layer of all is an Ubuntu LTS image. That's non-negotiable. The second layer will be the entry point, which is called Pebble. We'll talk about it later. So Pebble is the entry point, and then you can overlay your application in the following layers, and Pebble will run your application for you. And then we end up with the metadata that we were talking before. All Rocks have enough metadata, and this will continue growing for applications to actually understand where they are. So again, Pebble, who knows what Pebble is? Okay, so just a quick rundown. Pebble, you can see it as a sort of something which is very similar to Supervisory or S6. It's a sort of process manager, right? We use it as an init system in Rock, so it's PID1. But you can declare, and I can declare because it's all YAML, you can declare multiple service processes and let Pebble run them for you. And you can manage them as units. So what this gives you is this kind of orchestration of service processes as an organized set. So if your application is actually composed of multiple processes, which is very common, you can split those into different units when you are building the rock. And then at runtime, you can manage each one of them individually through Pebble. So even if the container is running, you don't need to stop the container or use Docker or Kubernetes to manipulate what's running inside. There's already Pebble inside that you can use to say, okay, I want to see the logs for that specific process alone, or restart a other process, or do something with it, right? Then, by knowing that, and knowing that all rogs are powered by Pebble as an entry point, the interface will be the same for all rogs, right? Obviously, the application parameters will change, but the way you manage those processes inside will always be the same. So that's a consistency layer. So again, and mostly if you are not going to the exercises, or if you have any problems doing the exercises, because we'll need network, and network, depending on which one you're connected to, can be a bit flaky. If you wanna, during the downtimes or doing the exercises, try out one of the rocks we have public through Docker Hub or ECR, you can just pull any one of those, give it a try. An hour later, it's free. So that begs the question, what is Rockcraft? And the description could be much bigger, but just to keep it simple, Rockcraft, as the name said, is the tool to craft rocks. So why do you want Rockcraft? And just notice the very nuanced detail on the top. Like, you don't need Rockcraft. Why? Because rocks are not its own thing. They are just OCI compliant images. So in theory, you could build a rock with a Docker file, okay, and with Docker builds. However, it will be much harder, okay? Because again, there's this specific set of requirements and a very specific design that you need to enforce manually through your scripts and recipes, if not using Rockcraft. So if you do use Rockcraft, and we do suggest that because it brings in a different level or different perspective onto container building, remember that this is from Canonical. So rocks are designed by Canonical. Rockcraft is built by Canonical. So as rocks evolve, because they will, Rockcraft will evolve with it. So if you have your rocks being built through Docker files, that kind of in-sync maintenance needs to be kept by you. You need to always keep an eye for what changes are there. So it's from Canonical, from Ubuntu to Ubuntu. It focused on the image. So it kind of abstracts all the nitty-gritty details of building an image. Because it's declarative, you are not scripting anything. And all of those repetitive processes, like you need to compile a Java application or you need to compile a Go application, it's always the same thing, right? So let the tool do that for you. Just give it the source code and the tool will just compile it for you. You can parameterize, you can configure how it does that, but by default, there's a way to build applications for different tool chains in a very repetitive way. So let the tool abstract it for you. There's compartmentalization as well. So it's actually similar to Docker because as you know, if you do a Docker build, the build will happen inside containers, right? Here it's the same thing, but it actually supports other build providers. It's LXD, you can do it on a host, and you could also have it on multipass if you wanted to. And again, it's just familiar because if you have used other craft tools, it's the same declarative language, the same parts, we'll talk about parts later, the same definitions that you have for Charmcraft and Snapcraft, Rockcraft inherits those. So it just becomes easier for anyone at any level, whether you are an ISV or someone who's a bit more tech savvy, it just makes it easier, right? You can still do all of the imperative things. If you want to script stuff and go very deep into what the build should look like, you can still do it. But if you want to keep it simple, it's all YAML, no code whatsoever. So a Docker file is to Docker build the same way as a Rockcraft YAML is to Rockcraft. Okay, that's the input recipe. That's your YAML file. And now we start doing things a bit more, let's be a bit more playful. And this is a sample of a functional Rockcraft YAML. If you give this to Rockcraft, it will spit out a rock. Now, just to see if you are still awake. Can anyone tell me what packages are being installed in this rock? I don't have cookies, otherwise I would throw them as a reward, but just, yeah, make a guess. Python, right? Python, right? Python 3.8, right? No need to apt install -y, minus no recommends, minus delete this, see you tomorrow, whatever. Just Rockcraft will do that for you, okay? And we'll do it in an efficient way. So you don't keep caches. Yeah.
Now I have one question.
Yeah, go ahead.
When I want to make a rock, and can I also take the source code of one of its components, of its part of its services, right from GitHub, so that I take a GitHub hub URL and specify also a tag in this GitHub.
Yeah,
URL.
you can.
This would also mean that the workshop, if someone has attended it right before lunch in beta 2 about Snap update automation, it would probably with very little changes also apply to rocks.
Yeah, you can. I don't know if we have an example here, maybe later on, but if we don't, we could try one. But yeah, basically that's all about the source. Here,
I think the only problem is that one must make the script sensitive, that one, its parts, it would probably work, but probably that it analyzes services also.
Yeah. So yeah, we will change the source later on. Right now, this is using a local source, which is on the GitHub repo I shared with you, but we could use a remote one for sure. So, second easy question. What will be the base? Well, I just gave it out. What's the release the rock will be based on? Focal, right, yeah. Okay, easy one. Okay, a bit more complicated now. What will be the output? Well, not the actual output, but what do you expect to happen when you do a Docker run of the resulting rock? Right. So notice the services. Yeah. That's the input to Pebble, and each service has a command. So in this case, we only have one service, and that's enough, right? But when you run this rock, you will have Pebble start a process running Python 3.8 app. Okay, I could have other processes, and they could actually depend on each other. I could say start process foo after rock server, okay, which is quite useful for container images like databases that require the daemon to start first and then some sort of script to kickstart the tables or user or whatever, right? This kind of dependency, it's really hard to achieve nowadays, and you will see plenty of Docker images out there with quite cumbersome and convoluted bash scripts with a lot of conditionals doing, oh, if the argument is this, then I'll do that, start this, then start that, exec. So no, just this, okay? Now, one of the fundamentals of Rockcraft and other craft tools is parts, and we'll just dig a bit further into what parts are, just so you understand, because that's the thing you will be playing with the most during the workshop. Now, I don't want to go too much into detail about this picture, also because it's like sort of a sketch, but all I want you to know is that parts are like the fundamental components of the craft tool, right? This is where you define what should be built, installed, staged, primed into your rock, right? And parts can depend on each other. So the important part here is that parts, they have a life cycle. So when you have a part, what Rockcraft will do, or any other craft tool, it will pull whatever dependencies, software, whatever it's needed to actually build what you are trying to build. So in that case, it was a Python application and whatever packages you need. Then there's an overlay step, which is basically if you want to install a package or run some script on top of the base that you have, you use an overlay. Otherwise, the parts lifecycle runs on its own separate environments and then goes into the base. So that's a deep detail, so you can kind of not worry too much about overlay for now. But then you have the build. So you pulled everything you needed for the build, whether that's a source from GitHub or a package from somewhere. You build your source code, in our case, Python application. You stage that compiled application or whatever you have to stage there. And finally, you can even select what gets into your final image. You can prime from that staging environment what gets into your rock. So all of this happens behind the scenes, right? Just know that because we will see these words appearing in the YAML file, like a stage package versus an overlay package. That just says at what stage during the build do I want this action to take place. And for each part, this is the life cycle, okay? Now, if I had another screen, I would just put this here. This is a sort of cheat sheet of the terms we'll be using a lot. You've heard a few of those, OCI, OCI image. I'll just do a quick rundown. The presentation is attached to this event. So if you want to get this, feel free to get it. But just very quickly, OCI archive is an OCI image, but as the tarball. It's what I was saying before. It's the actual raw format of a container image, right? All container images are tarballs, and OCI archive is the tarball. It's just a different format, okay? The OCI entry point is the actual image entry point, the OCI field that states what should be started when your container starts. And the OCI user is the user running that entry point. Then we have the base. We mentioned it a few times already. It's for Rockcraft. It's the Ubuntu LTS release, or Bear. We'll get to that in a few seconds. It's the base upon which you will build your rock. But you have also a build base. So this one is an important one, right? Base relates to the final rock, right? I want my final rock to be based on this. Build base is optional, right? If you hide it, if you don't specify build base, Rockcraft will just use the same release as base. However, there's the power to say, I want to build all of my software that go into the rock in this Ubuntu release, but then use this base instead. Okay, and this is quite common if we try to do these treeless rocks, which we will do later. Okay. Parts, we just talked about them, that life cycle. And we might not need too much of this, but just for the sake of being complete, we have craft environment variables. So Rockcraft accepts a certain amount of predefined environment variables that anyone can use to help out with the building process and staging process. So if you ever need to, for example, manually script something that you want to end up, you want it to end up in the final rock, there's a set of environment variables that will help you locate those things and place them in the right folder for staging and priming. So it's just this, you can see those as helpers. You don't always need them. I don't think we have any exercise. Maybe we do have one exercise with them, but just know that this is all documented so you can see which ones are useful, which ones you might need to use. The part lifecycle, that's the graph we just looked at. So pull, overlay, build, stage, prime. Plugins, I don't know if you noticed, but that's where the abstraction takes place. In our sample, we were using a Python plugin, which means whatever build dependencies you need, whatever processes and compilation scripts are needed to compile your application, the plugin will do that for you. So it's an abstraction, okay? And also plugins are documented. You have support for Go, Node, Python, and so on, okay? And finally, services, it's the Pebble thing. It's what defines what processes will run when you start the container. Right, so if you haven't cloned the repo and you want to follow along, now it's the time. Our friend that Paul will help us out here.
I didn't do great this, but
Don't fall.
Don't fall.
All right. If you want to do it again, do it now. Otherwise, what we can do, I'll give you a minute if you haven't done this. Are there any questions so far? 3, 2, 1. No? All right. Install Rockcraft. If you don't have it, it is published as a snap. Right? I don't know if you noticed the description for the workshop. You might need other things. Like for this workshop, we'll need LXT because we will run Rockcraft with the LXT provider to compartmentalize the builds. If you don't have it, you don't feel like installing it right now, I can show you, or Sergio can show you a trick later on to run Rockcraft without any compartmentalization, but if you do so, I recommend you do it from a multi-pass VM or an LXD instance, okay? So let's change here. Okay, I'm inside my GitHub repository, so you will see this structure. Let me make this bigger. It's enough, I guess.
It's too big.
Right. So this is separated by modules. So right now we are on the how to install Rockcraft. Quite simple.
Might need to mention. Yeah.
Okay.
No, an Ubuntu environment might be easiest.
In the Ubuntu environment.
Yeah, in case someone's like on a Mac or something.
Yes.
Yeah. What do you mean?
If someone's on a Mac.
Yeah, we use a multi-pass. Yeah.
Yeah, or a VM.
Yeah. So yeah, if you don't have Ubuntu or if you don't have LXD, just spin off a Ubuntu VM.
But whatever.
Virtual machine, the workshops app can help there because where you can or open virtual machines of any distro.
All right. So if you don't feel like going through all of it, I'll just do it with you. So you must have Snap. Again, if you don't have Snap, try with a VM. In LXD installed. Again, if you don't want to install LXD, Sergio can help you. Just raise your hand and Sergio can tell you how to do it without LXD. Scopio will come with a Rockcraft. So there's no need for you to install Scopio for now. Docker installed. If you want to try the Rock afterwards, we will build a couple of rocks. We'll run them. So we'll need Docker for this. If you have Podman or any other container runtime, that's just fine. And well, a text editor. So either you use Vim or don't use anything at all.
Emacs.
Version 1.0.0 does not.
Must be Vim.
Vim is for those that haven't discovered Emacs.
Right. So I already have it installed, but Rockcraft, it's a classic snap. So this is all I need to run. Okay. I already have it installed, but you can get it finally now. Sergio already published it on stable, so you can get it from stable. If you wanna get it, from the Edge channel, you just do ---- Edge. But actually today it's probably the same revision. So that's how you get it. I don't know if you are having any trouble. Just let me know. Okay. So once you have it, you can try and run a few commands. First, we are running Rockcraft 1.0. Okay. If you have ever used other graph tools, you will find the help information quite familiar. It's the same structure, same commands. You can expand the information with --whole. Okay. And what we'll be doing the most today is using the pack lifecycle command, okay, to actually go through the entire lifecycle and create the final artifact, which is the rock. All right. Any questions so far? Nope. Okay. Let's continue. Now, the second exercise is actually building a rock. Okay. Now, you will need the repository to do this because I will use the sample from before where there is a Python source code. So the Python source code is a very simple web application, but it is in that Git repository. So get it if you want to build the same rock. And all you need to do is go back to module B. Okay. You will see something like this. So you have source code, a README, and Rockcraft YAML. This is the rock that I've already built. Okay. So just as a reminder, this is a YAML sample you saw before. No changes whatsoever. Okay. So what we are expecting is an Ubuntu focal rock with Python 3.8 and a Flask application will be running inside. You don't know it's Flask. Why? Because it's part of my Python projects. And the Python plugin from Rockcraft will just take care of that for you. So you don't need to install the pip install Flask or whatever dependencies. Those are part of your Python projects, and the Python plugin will just do it. Okay. So how do you build a rock? Well, let me first open the README just so we don't forget any steps. Right? You just do a Rockcraft pack. The -v just to get a bit more verbosity. Okay. You can also go to the extremes of doing it with debug, and you can out of logs if you get into troubles. But as a starter, I recommend using -v just to see what's happening. Now, I will give you a couple of minutes for this for two reasons. Number one and number two. So that's it. The number one is that if this is the first time you are doing this, you will probably have to wait some time because Rockcraft will download the LXD instance, the base that we'll use to make the build, and then also download the Ubuntu based container that we chose here, which was for. In my case, I already have it in cache, so everything was quite fast. For you, it could take a couple of minutes. And reason number two is that network kind of sucks. So if you are on the hotel network, I highly advise you to switch to the canonical Summit, Ubuntu Summit, right? That's how it's called, yeah. Switch to the Ubuntu Summit 1. So that you don't have loss of packets or instability whatsoever. So again, I'll just continue slowly just to give you time to build this. If you start panicking, just raise your hand if something is going. You're panicking, Samir, tell me.
I'm panicking, yeah, but as you said, I don't have the base image locally.
Yeah.
So what would it connect to? It's showing failed to list projects on remote local.
What network are you on? What network are you on? With Wi-Fi?
Canonical.
Canonical should also be good or not.
Yeah, if it's a hotel one and you're getting hotspotted, maybe.
Yeah.
Yeah, try if you have. I actually have again. If you have the repo, there are a few troubleshooting guidelines here. If you get into troubles, if you are having networking issues, there's one known issue which we can actually not do much about. That is, if you have installed Docker from the archives instead of a snap, there might be some networking conflicts. You can run that command up there just as a kind of quick fix for networking issues.
I did install Docker from the archive.
Okay, so try running that right there to avoid any networking issues from inside the LXD instance.
Essentially what happens there is that Docker takes over all the bridges you have on your and destroys the LXD bridge.
And worst case scenario, if you keep having issues, just probably this could happen for people that have tried Rockcraft in the past, but like older versions. You could have an already existing LXC instance in your system that might kind of be incompatible with your version. So just do a cleanup of the LXC instances you have. If you keep having problems, do an LXC -- project Rockcraft list, see whatever you have there, and just if it's safe to delete it and restart the build.
I'm here in creating new base instance from remote, and it has already 276 seconds. Is this still here?
It could, right? I mean,
Do you have Docker installed?
I will look.
if you are seeing long pull
Run the
times,
verbose.
yeah, exactly. So if you are seeing like weird behaviors, do it with either debug or trace.
I have a Docker snap installed. Which is
So if you want to do it, I'll show you here. It's
my Docker is from latest stable. Is that this book one?
from the snap.
Yes.
So it's
20.10.20.
yeah. So 200 seconds. I've seen it taking longer. It really depends on the network. I mean, if it goes much worse than that, then
Total snaps, so she shouldn't have.
it should not have that problem. But again, if you want to see what's happening, like if the pulling is taking too long, it's just minus verbosity.
Does this mean when I've already snapped on this laptop, it must be faster when I never snapped on this laptop?
If it is the same base, yes. But remember that
because-
Rockcraft will pull the image,
Yes.
right? So you want fresher images, right? So if there are
Because
updates,
I'm regularly snapping and I've I've given a snap workshop right before this one.
yeah.
But I've not snapped on it. I've only done GitHub and only the others not me. I've only shown slides.
All right. So I've just done the same thing as before, but with repository to debug.
Would the
Right.
base image be the same if you do that through Docker?
Tell me again.
Like I understand that the init image in here, the base image is like, let's say Ubuntu 2004.
Yeah.
So if you're gonna go away from Rockcraft and use solely Docker, is the same if you pull or if you have your base image as 2004?
Yes.
Well, is it
Yeah.
gonna be the exact same thing?
Yeah, Rockcraft is currently using the Ubuntu images from ECR.
Right.
So whatever you are pulling on your Docker file, it will be the same because the Ubuntu images in ECR, ACR, OCIR,
Yeah.
Docker Hub, they are all the same digest, all the same images. Every time we update one, we update all of them. So, and Rockcraft is using those, so it's not using something else different.
But there's no way to change or to go away from Ubuntu as a base image, right?
No,
All right.
there's no way. There's the sneak peek, there's the bare base.
I've seen that.
Okay, the same way for snaps, there's a bare base. You still are building things on Ubuntu, but then shipping without all the distro stuff.
Right.
And you can have and when I have built the OCI container with Rockcraft, it has inside the container, it has Ubuntu.
Yeah.
But can I install this resulting OCI container on other non-Ubuntu operating systems?
No, that will never work. It's either Ubuntu, and if it is Ubuntu, it must be LTS or bare. That's it.
I only want to know because I'm leading open printing and I've snapped cups. And I want to also have an OCI container of cups. And this should be available for as many users as possible.
Yeah.
Because there are many immutable distributions which do not support Snap. They are supposed to use Flatpaks for desktop apps.
Yeah.
And for system apps, one would need OCI containers.
Yeah. I mean, in the end, the OCI container will run on any distribution. The container just runs on any distribution. It's a container. Remember, OCI is
Yes.
portable. So this rock has been built with Ubuntu, from Ubuntu LTS. But I can run it on
Any distribution.
Windows. Yeah, I can run it on Windows, on Mac.
Yes.
Yeah.
Yes, so that someone tells me with Windows I cannot print that he can install this work.
Yeah, of course. It's
And then he can print
Yeah.
a Windows.
like any other Docker image, no problem.
Yes. Because this Microsoft still did not switch to cards.
Yeah. All right. We can do one interesting thing, which is remember the parts life cycle. There's the pull, overlay, build stage, right? One cool thing you can do with Rockcraft that you cannot do, at least not easily, with Docker builds, is that you can actually stop the packing process at any stage of that life cycle, shell into the LXC instance where things are happening, and just see the state of things. So for example, if I say pack, well, not pack, I want to stop right after prime, which is right before my rock takes shape. Minus, shell, after. So it's basically going through all the lifecycle steps again, pull, overlay, they are all cached, so it should be fast nonetheless, but it will go through all of them. It seems to be taking a bit too long, but I still have network. So. Yes. Okay, seems to be going. We also don't see, oh, sorry, yes.
Just had a quick question. Is the network conflict with Docker, is that something that's new from the 1.0 release, or is that
No. It's always been there. It's just a matter of some people might never have seen it because I don't think there's a conflict if you have installed Docker from snaps.
Okay.
So fewer logs because I didn't pass -v, but still you see that my shell has changed. I'm now inside the LXC instance. If I do ls, I can see my projects, okay, because I'm on the project directory, okay. If I go back, I can see different folders, the staging folder where I can find, let's see what's inside. It should be like the Python stuff should be inside. So let's see, user bin. Yeah, this is all stuff that has been kept from the Python plugins and whatever.
What are the dependencies of Python?
Let's see, where do I find?
Python was there.
No, yeah, Python was there, but that's not what I'm.
Looking for the
Yeah, I'm just seeing if there's something like super obvious that we can find.
lib, lib Python site packages.
Yeah, okay, yeah, that's a good one. All right, you see Flask. Yeah, good point. That's a good one. Flask is here. Oh, that's actually that's a good point because there's also the app here, right? That's our app. Okay. So you could stop at any time. Now, if you had the time to do it, you should end up with a .rock file. That's the rock as an OCI archive. Okay, I'll show you in the next module how you can run it. But for now, Rockcraft spits out in an OCI archive format. Again, it's a title. And our image is around 61
Can I
megabytes.
get my LXD? I think it does not. It is not able to build the rock and
Yeah, so
how can I clean my LXD?
yeah, so try this, for example, on the screen. Try from the directory where you are doing this.
I don't see it from here.
LXC dash project.
LXC.
LXC minus projects, Rockcraft
And Rockcraft.
Oh,
list.
And then there's
this.
And you will see a table.
Yes.
It will either be empty or full of stuff.
There is one entry,
Kind of.
one single entry in the table, base instance, base v3 go up and then
Right,
on it's running.
right. So now you have two options. If you want to be conservative, double check the Rockcraft logs and see if the name matches. If that's the same instance, delete it.
Yes, the Rockcraft fails for me, the Rockcraft command, and therefore I'm asking.
Mhm.
And what should I do then?
Then you can just try two things. First, Rockcraft clean.
This I tried and tried
Then-
again and failed.
Then just do the LXC command again. So LXC minus projects Rockcraft. Delete that instance name
Yes.
and try again. All right. So on to the next exercise. Yeah, tell me.
I'm getting an error on Hack with quite long the engine cannot reload user rules in a search files directory when I'm trying to patch.
Oh, that's the trickier one.
What's this right now? Sorry, what are
It seems that the interface name is not getting reproduced and it does not find
Give
it.
me a second. What was it?
I think it's changed.
Did you do it with a verbosity? Do you have more logs? More logs?
It's full execution log is someone else.
Okay, let me. Let's. If you cannot move on, I'll meet you during the next exercise.
Inject host snap Rockcraft into target environment.
Is it really running static container? Yeah, that's what it is.
Okay, let me find you in two modules. So let's just, for the sake of completeness, move on to C. And in C, we are going to inspect and run the rock, right? So we have the same rock from before, the Flask rock. Now, how can you, oops. How can you play around with this file? Now you have a tarball and you want to pass it to Docker. You want to see spec the metadata of this rock. What do you do? Now we use a tool which is actually being shipped with Rockcraft, so you don't need to install it. It's already in your system if you have installed Rockcraft from this lab. And this tool allows you to manipulate OCI images in whatever format they are. So I'll give you an example. Scopio, and let's say I want to inspect the OCI archive called myFlask app, blah, blah, blah. Okay, there we go. I have a few labels that Rockcraft sets for you. The name of the rock, the title, the version, the architecture. You are used to it. If you have ever done a Docker inspect, it's very similar. Okay? What I can do now is that I want to run this, but Scopio is not a runtime. What I'll do is, instead of inspect, I will copy to the Docker daemon. Let's call it test, whatever, test latest, right? So Scopio, just copy the tarball into the local, let's call it the local Docker registry, right? And now I can just do Docker inspect test. So pretty much the same thing as before, a bit more information, but it's still myFlask app, version 0.1, AMD, and so on. Okay. Docker run. This is a web app, right? So let's say -p, 8080. I think it's on 8080 as well. Test. Okay. A few things to take note of here. First, it's Pebble who's running the Flask application. It's not the Flask application running itself, it's running through Pebble, right? So I could do a few things now, for example, from a different place, I can Docker exec the container name, whatever that is, it's the only one I have. So Pebble services. There's one called Rock Server. Pebble, I think it's log, Rock Server. Logs, maybe. There you go, logs. Okay. If you want to tail the logs, -F to follow. And whether I'm inside the container attached to it or from the outside, now I'll just go to my local host. Oh, sorry, it's actually on port 80, so let me stop this. Port 80, so 80. Let me follow the logs again. Now the container name has changed. Right. There you go. Right. So, and we should get the logs here. So Pebble is pretty much doing the same thing as above, but I'm doing it I'm doing it from outside the container through Docker. The other one I'm just attaching to the SD out of the Docker runtime. Okay. I could do some additional things that in this case does not make much sense, but just to illustrate what you can do, I can stop the server. Okay, and now the container is still running, but I've managed the process from outside the container. And this was the link here was a nice thing from Rafi who did this. But I'm not going to take the ad blocker, I'm sorry.
Incognito window.
I reached the 3 videos a day. Oh, sorry. So now there is no server anymore because I stopped it, right? But the container is still running, so I can start it. It's there now, okay? So it might look as if you would say, I can just do that with a container, I stop and start a container. In this case, yes, because you only have one service. What if you had 2, 3, 4, 5, right? You can take care of the life cycle of one specific process, service process, while the container is running, without having to mess around with Docker restart policies and Kubernetes probes and whatever. Okay. All right. So what else? Yeah, that was pretty much it for the inspection part. So now, still have, some time. I want to actually, if you are doing the exercise, I would actually like you to do the next one with me like side by side, because that's probably the coolest one we will do. Okay. So for the next one, we are going to turn this Python proc into a chiseled rock. Do you guys know what chisel is? Right, so do you know what distillus is?
Yeah.
I'm giving a talk about it in 30 minutes. So this should have been the other way around, but so if you don't know, like, because of those concerns we saw at the very beginning, and containers are so old right now, not old, but they have been around for so long, that people started thinking about how can we better optimize this. And because we want secure things, we want secure containers, one of the easiest, between quotes, easiest ways to secure the container is just to remove the things from it that we don't need. I think about it. My first sample is based on Ubuntu Focal, but I'm running a Python application. Why do I need curl? Why do I need wget? Why do I need bash? I don't need any of that. And I'm not saying that those things are vulnerable, but they could be. So distillus is a concept where you only ship your application and whatever it needs to run. Okay? Now, this seems nice, and it is nice, but it's actually only nice if it is well done. And what's the problem? First, it can be hard to do. The usual approach nowadays is that people just build a very big image in one stage and then cherry pick down whatever they need to another stage. So you are doing a manual process of, I want that file, that file, that file, that application, that configuration file. It can go well, it can go terribly wrong as well. So they don't use package managers. What Chisel is a canonical product to allow you to build distillus container images with a distro field. Okay? Chisel is like a package manager, but instead of installing devs, it installs slices of devs. You take a dev, we say, okay, this dev has 30 files, but I actually only need 5 of them. This is a slice. This is predefined somewhere through YAML files. And at build time, when I use Chisel will look into those YAML files, take those slices from the dev packages, install them in the Rock. And you get an Ubuntu distro image, which is kind of paradoxical, but that's actually what you are doing. And you do it from the ground up. Instead of building something big and then trimming it down, no, you start from scratch, chisel something, bring on those packages without having to install apt or any other dependencies whatsoever. So to do this, we are going to module D, and we are going to use the same YAML from before, but there are a few changes here. So I want you to guide you through the changes. So the first one is that our base is not focal anymore. Now it's called bare. Why is it not Scratch? If you are used to Docker files, you see Scratch. Because it's not entirely Scratch. There's always something in it. There's the Rock metadata, there's Pebble, right? This you cannot run away from. So a bare is what is our interpretation of Scratch, but it's actually a little bit more than Scratch. Which means if you have a bare base, you need to tell Rockcraft how to build your things. And we want to build our stuff, still, we want to build it in focal. So build base is now focal. Okay? If you omit the build base, Rockcraft will just think, okay, I need to build stuff in bare, but bare only has Pebble and metadata. I cannot build anything. I don't have the utilities to build anything, right? So in this case, when your base is bare, you need a build base, always, okay? Second thing that changed. Well, this is more of a need, like I need to do it. I don't really want to do it, but I need, because one of the caveats of doing chisel stuff is that you are building from the ground up and you don't have all the utilities that you would have with something like apt. As you know, if you install a package, you have maintainer scripts, for example, right? Maintainer scripts require depconf, and they will use reconfigure every time they install as a post configuration script. You have a bunch of stuff. Like certain packages have a lot of scripts attached to them as hooks, right? We cannot do all of that, at least not yet with Chisel. We can do scripts, but we don't have all of those utilities around. So one of the things we need to do for this image is that we just need to tell the Rock where the Python modules are. That's all, okay? It's a small bird, but just so you know. Then, same service as before. I'm actually not calling Python anymore. I'm just calling the app because it's there. It's part of the path. Same source. The Python application hasn't changed, but now there's something different. Instead of installing Python, I'm installing a slice of Python. This slice is defined somewhere. I can show you. It's in GitHub. There's a repository with one branch per Ubuntu release. And in this branch, you will find a folder called slices. For each Debian package, there is a slice definition file. Okay. This database is quite short at the moment. This is a community effort. So people with new packages or existing packages, we ask them to kind of contribute the slice names. But if we go here to the Python slice that we have done, so it's in focal. So I have to go to focal. There's a standard slice that depends on a bunch of other slices. So core, which is here, that depends. So it's the same train of thought as for devs. You can have inter-slice dependencies. You can trail them the same way you can do that for devs. So in the end, what matters is that standard will depend on a bunch of other slices. And for example, if we follow one of those, Python 3 minimal, for example, Python 3 minimal beans, it's basically saying from the Python 3.8 minimal Debian package, I only want this file, this directory, and this directory. That's all I want. I don't want man pages. I don't want configuration files. I don't want anything else. I just want this. So how do you know if it is a slice or a package? Do you know that? So what character cannot exist in Debian packages? Underscore. So if you see something in a Sage package, overlay package, whatever, if you see an underscore, it's because whatever comes after the package name is a slice. So it's the standard slice from the Python 3.8 package, and it's the lib slice from libgcc s1. We need that one just for the example. We'll need that one, but and that's it. I mean, just a few more lines. We pack again. Pack. Let me put this down. So if you are following this one, again, it should be faster now because you already have the LXC instance installed. I got it here. Before I do anything with it, I just want to version 2. Remember, the other one a while ago was 61 megabytes. Yeah. This is 25. The question is whether it runs or not. Very pretty, but it doesn't run. So I'll just do the same thing as before. Scope your copy. This time it's version 02. Test, let's say 2. All right. No pressure. Right? Is it actually running?
Says that. Let's see.
Actually, don't know. It's not. What could have gone wrong here? Oh, okay, just took some time for some reason. I don't know why it took time. Anyway, so 25 megabyte image, which is, well, almost 1/3 of the one before, doing the same job as before. And it's still with Pebble, so I could still do the same thing. Docker, exec, error, Pebble, services again. By the way, the other reason why Pebble is cool is because you might wonder, well, I have a distro image, which means I have no utilities. How do I debug distro image? Like if it at runtime, it's deployed. I'm having problems. I need to see something inside. Pebble. Pebble LS. I can look into the I have inside my container. I don't have LS installed inside the container, but I have Pebble, which has embedded utilities. For now, it only has LS and make clear, but we will have more in the future.
Isn't that also potentially a security concern at one time?
Yeah, it's part of Pebble, right? So we have to be careful about what utilities we put inside, but those are all part of the Pebble code base, which is already anyway inside the rock. So as long as we keep Pebble secure, whatever new things we are safe, and we control that. So it's not like we are going to go to your question. Initially, we thought, let's just make Pebble make use of a sort of sidecar busybox container. And then we mount our container to the busybox. That would be a security problem because we are outsourcing the utilities to someone else. In this case, we control what we put inside. But yeah, the more stuff you put, the more likely you are to encounter problems and to make the image bigger. So we need to be careful. We are only going to put the essential utilities. We are not going to explore Pebble. All right, we stop this and make sure I didn't forget anything. Yeah, so that was basically the exercise. Just to recap, we changed the base to bare. We installed the slices instead of the whole package, and we had to set these environment variables just so the image knew where to find the Python modules. And everything else was the same as before. So that brings us here. Now we have Nancy, which is perfect. I wanted to save 20 minutes for this. If you want to do it, by all means, from left to right, easy to hard, you will find all the details on the GitHub repo. Each one of these, so I'll just show you here. cd --, module E, do it yourself. You will find challenge A, B, and C. Okay. Challenge A, you have the README. Okay. This will guide you through all the requirements. So for example, for challenge A, I'll just give you the quick rundown. We want a rock, standard rock, that starts an Apache server. Requirements: the rock must be named challenge A. It must be based on Jammy. And when the container starts, I want the command to be Apache to CTL. Just copy paste this thing. No need to go into details about the square brackets. This is a Pebble thing that allows you to define default arguments that you can override at runtime. But you can just copy paste. You don't need to delve into the Pebble things, and then make sure it runs. And you want to see. It's not printing the image, but I have the image here somewhere. Should print it, okay? Now, you will see the solution there. Please don't look at the solution, okay? I'll show you all of that in the end, okay? So this was option A. Challenge B is about going to the repo. You will find the Go application. I want you to use the Go plugin in Rockcraft to compile that application, which is a very simple assistant, if you want to call it that way, and make that Go application your entry point service in Rock. So when I start the Rock, I want the assistant binary to run. The third challenge, and that one is a bit trickier, but I will give you a stamp. If you can make it, you'll become an official contributor. Because if you can make challenge C, it implies using the same sample Rock that we have just done, but do it for jamming. So you remember the chiseled Rock that we have just done? It's Python 3.8 on focal. So challenge C here, if you are up to it, is for you to do the same Rock, but on jamming. So why is it hard? Because there are no slices for Python yet on jamming. You have to make your own slices. If you are able to do it, please make a PR to the chisel releases, become a contributor. Yeah, I will help you out if you want to, because there are a few things you might need to know. But if you are willing to take this challenge, we have 20 minutes. I'll help you out. Should be enough. It actually should not be that hard because you can just start from the slices that already exist for other releases. You might need some adjustment. You will need to see what contents are missing here and there. It's package management and just YAML definitions, but you'll be able to make it. Might take more than 20 minutes, but if you want to do it afterwards, the PR is still very welcome. So I will show you some of these solutions when we are about 5 minutes away from finishing. For now, I'll just be going around. If you have questions, just tell me. Right? Okay. Yeah. Sorry, the questions. Go ahead. Start giving them questions. Yes.
Yes, I'm hoping to get this Rockcraft pick going.
Okay.
Because the LXD container is somehow has a problem and I don't get it deleted.
Okay. I'll get Sergio there to help. Yes, you?
Yeah.
Yeah.
If I want to automate the whole process from the creation of the rock to the
Because
chisel, how much stable it is if, for example, the developer wants to change the code and add Python libraries, for example?
If you want to add additional libraries.
Exactly. I mean, imagine that okay, I managed to automate the whole process, and whenever the developer commits, then we trigger all the automation and we get everything perfect. But if the developer changes the libraries that need to get into the final,
Why do you want to delete it?
final chisel container.
Yeah.
Can I automate this process, or do I need to go and add it to the building process of the?
So it depends where your libraries are coming from. So for example, in our example, I had a Python application.
Yeah.
In my Python project, yeah. So in my Python project, that's where I define the dependencies, which means
Very at the beginning, yeah.
yeah. So the Rockcraft YAML hasn't changed. So your automation would just still work. The Python plugin from Rockcraft would look into your TOML project. Oh, there are new PEEP modules that I need to get that were not there before. So it will get those.
But for the chisel rock, is this the same?
Same thing.
Well, the base change implies that you might be changing versions, as you know.
Yeah.
Python 3.8 is in
Exactly.
vocal, and you'll need to change that to 3.10. But I'm sort of giving the solution away, so I'll talk about that.
Yeah, but that's the thing, right? I mean, if
I do change,
Yeah.
expect that.
that would happen on any other build process, right? If you don't specify, for example, if you just say Python 3, the system will just default whatever its latest, right? So if there are updates upstream, right, you'll get those updates. The rock will be different anyway. So if you are looking, if your question was more about, can I have a process that automates the build of this rock and always get the same thing, then we start getting into reproducibility. That's a bit trickier, right? Because things change upstream. And there are also timestamps that happen when you build something that get embedded into the rock. All of that will change the digest, so the rock will ultimately be different, even if the quantities are the same. So that's a different domain. But yes, if you have additional stuff that you are changing either in your Python project or
whatever application you are shipping with. Or if there are slices that have changed upstream, the Rockcraft YAML can be the same and still fetch those new things.
It's a little bit connected. If it were a Node.js application,
Same thing.
you can have the same thing.
In principle, yeah.
Yeah.
I don't have an example here, but yeah, the plugins will do that for you. And we have plugin. How many plugins do we have?
Really? There is an NPM plugin,
More than one.
but I can't list them.
But yeah, there's a plugin for now.
Then maybe follow up when you do multi-stage builds, you can try to like optimize the downloading of the npm packages. You cache the slices. Would that also work?
Did you explain this how the difference in Docker run versus this?
Docker run.
Versus this?
You can talk about.
Yeah, sorry, Docker build, thank you. Yes. Did you explain that?
Not really. I
So
can't.
the multi-stage thing, I guess, is that you change, you stage in Docker build multiple things, and then you change the last part. The craft applications work differently. All the caching happens on the build environment, and there's only really one layer, if you want to call it, which is the prime directory, which is from the original architecture Cristovao showed. It's where you essentially put your application. So there is caching, but it's not the same concept as Docker, where each run command is cached as a layer, then so you don't need to rerun again. Once you have it installed, it's installed.
So in Docker, you get this thing where if you're trying to build an image as like with a different user, for instance, you can do that. So you can build like, because obviously if you build like an image with Docker directly, it automatically goes to root. So you can just build an image with like a nobody user. So can you do the same in Rockcraft?
Yes. Yeah. We are a bit more opinionated in that sense. We can do it, but we don't allow you to just set any user.
So a specific user has to.
Very good. So for example, let's use the sample before. In here, you could do something like run user, and we have this concept of shared users. That is a canonical, well, it's more than canonical, but it's a artifact-wide user definition, meaning that this user actually has a very well-defined UID group and group ID, not just for routes, but for snaps. Right, so it's common across the different artifacts. So if you do just this, let's see if I hope I don't have to clean the build for the running. I don't think so.
That's metadata.
There are a couple of newbie questions.
Yeah.
For building these images first time, so where does LSD get used and where does Docker get used?
Docker does not get used there only at all.
There's no Docker involved in the build time.
Oh,
And LSD is your choice. Like it's one of those providers. Yeah. You could do it. I could do it on the host itself if I want.
That'd be fun.
I see this OPO copy failing with policy JSON, no such file on that.
Scopio copy, no such file. Maybe Samir can help you. That's you probably. Huh?
It didn't have the trace for license. We didn't.
The policy.
Yes.
Yeah, just use -- insecure dash policy. Try that. Before copy. I think that's the thing.
Yeah, only 16 gigabytes.
is there a way to outside Rockcraft back?
Setting up the image, so that comes
We use the base instance with.
Yes.
So that-
Outside Rockcraft have the image. Which image?
So Rockcraft packet is mostly failing for me or waiting on building the new base instance from remote.
It's networking time on.
Right.
P7 stage.
I think it's the network. I'm also having an issue now. Okay, now
It's just slow. It's network. Because I saw he's running on a very slow machine apparently, and he's this time now.
So is there something specific in those images, or can they just be copied over from some?
You could copy the LXD image separately and then Rockcraft will just.
It's like C download really.
It's an LXD download.
That's what's taking long.
Yeah.
Network is saturated.
Yes.
So obviously this work, there's a lot of similarities to kind of parts, how you define parts and something like this. Could you expect very similar behavior if you wanted to, for whatever reason, take a snap and convert it into a rock?
Yes.
Could you basically copy and paste those parts over and expect very similar behavior?
Not in all cases, like you not just copy paste for all snaps, but in most cases the changes will be like slight modifications. I would hope.
Okay.
Yeah, I mean the parts.
Depending on
Are,
the plugin, it can be just copy paste.
Okay.
If you do any like specifics to make it work in the context of a snap, I guess you have to work with those. But then,
and by the way,
the logic is all the same.
if the question is kind of in the trail of, oh, I have a snap and I want to pack that as a container, you can just do our exercise and install the snap. Right? You can, instead of stage packages, you just install the snap into the container. Right, so if the snap already exists, there's no need to reproduce the same recipe. It's really network.
It is network.
Yeah, fetching.
Perhaps one needs for
You're taking care of it?
on the Ubuntu Summit 2025, we should have set a server here locally, a workshop server, from which all the materials for the workshops are served out.
Usually that was not slow. It is.
No. Yeah, but this week,
Yes.
I've seen it this week.
Yeah, my demo earlier today.
It's already up on 400 seconds now.
No, I will take one because this is doing mostly nothing with the network.
I mean,
It's taking long.
the image is what? It's not 1 gigabyte.
50 megs.
No, that's the container range.
Oh, sorry. What?
The LXC. The image where you run
Oh,
the
but
build,
that's assembled. Yeah.
Yeah.
That has the
That's big.
base, Rockcraft,
that's big.
all the build packages.
Yeah.
It's not one gig, is it?
I don't know. It is.
We just Rockcraft.
We have 10 minutes. Let me just finish this one. If it's finished, and I'll show you a couple of solutions for the. Is anyone trying challenge C? Oh, no, no one wants to become a contributor.
Wait, you can you don't need to try it now. So you can try it later.
We are still on the first B or C.
Only on the
Yeah, the network is not helping. Yeah.
Yeah.
Has anyone made it past networking issues? You have?
No, sorry.
Have you made it past networking issues?
Yeah, I had some networking issues that I'm getting and had to do something to switch over. Sorry, I had to switch over to Wi-Fi really.
I think we're all on Wi-Fi here. We're all on Wi-Fi.
But the one question that I didn't sort of have is where we find the documentation for so that we know, like what basis we can use, what,
Yeah. So the first one, it's a difficult URL to remember, of course, but if you are used to some of the canonical read the docs URLs, it's always the same pattern. So canonical dash the tool, in this case Rockcraft, read the docs. But if you don't want to remember this URL, you just go to the Rockcraft project in GitHub. So canonical / Rockcraft, and there's a link to the docs there.
Up there too. No?
Up there.
At it? Stops passing.
Docs. Yes. So we can follow the docs doing from there. But during the coming months, I think Sergio and I will be kind of reworking a lot of this. So there will be quite a few changes to the docs, hopefully, including maybe the location docs.
Including the location. An official Ubuntu host location.
Yeah, but the safest entry point is always the GitHub project because that will be kept up to date. That will not change. So start from there. Okay, I got it. Fine. So Scorpio copy this.
What was this demo again?
Run user.
Changing the user, yeah.
daemon, let's call it up test C. Does it run? Yes, it runs, but now the question is as what, right?
Yeah.
Did I do this for, this is B, so this is not chisel, which means I can do this. Yep, keep it running. And I can do something like Docker exec, name of the container, and where my daemon. And you could also just do this. I don't need to run the container actually. Docker inspect test B minus F. Config user, I think, maybe.
It was test C, I guess.
Test C. Right, let me show you just for sake of transparency, so I don't think I'm cheating anymore.
I don't think anyone thought that.
I don't know. It's like, oh,
Now we are.
it's like do these challenges, and you're like, maybe those are impossible. So, challenge A. Wait, A. Who? The Apache server. So very much like our first sample. All you need to do, replace Python 3.8 by Apache 2. It's the dev, and replace the service command by the one I put in the readme. And the base is 2204 instead of 2004. It's still in the old column. So that's one. And I have the rock here. Oops. I think this is normal, but I didn't share the ports. Let me share the ports so that I know which ones what they are. One, is it 80 maybe? I don't know. Already have something there. Two. Yes. Okay. Right. Challenge B. So challenge B was a bit more comprehensive because we have this Go mod. Well, Go mod is relevant. I have this assistant application. Okay. It's my personal assistant, my own ChatGPT that only does 5 things. Okay. So solution there. What do we do here? So, starting, I'm a bit narcissist, and I want everybody to know who did this. So I'm just putting environment variables just for the sake of putting in there. And there you go. I had an example with a non-root user. There was no need to redo it. So I don't want to run this rock as root. I want to run it as daemon. I want to run the assistant when I start the container. Now I will tell you about these square brackets. By default, do nothing but print the help information, but I'll do something with it afterwards. Now I have one part just for building my source code. So I have the Go application. I'm using the Go plugin to do the Go binary. And I'm telling the part that I want specifically to build this Go application with Go 1.21 from the Snap Store. So you can do this. You can basically say, okay, there's a part, there's source code, but I actually need this specific Go version. I want to build this code with that specific Go version. Now, yeah, the question from a while ago about the Git repository. I'm also adding, this was on the requirements, if you saw the README file, I'm also adding a random file from some remote repo. There you go. The source is a Git repo. I'm dumping file, what file? The README file from that repo. I'm calling it nodes and staging it to the final image. Okay. And I'm also doing, I think I need to do something more complicated. So I'm doing some scripts. I can just create another part, no plugin needed. And I will override the build for this part by saying, I know what to do here. I don't need any plugins. I will do my own scripting. So I will create a directory. This is one of those special environment variables I talked about before. It's basically Rockcraft telling me, I don't need to know where things are being placed. I just need to use this macro and Rockcraft to make sure that my build directory, my build folder, is in a path that will end up in a rock. And this path is called craft partners.
Each part builds independently.
Yeah.
It's not like cascading or independent. Stage, Cristovao mentioned earlier, is the sharing area for all parts of the code list.
So let's copy this. Walk around, around. Okay, there you go, my assistant. Had a few functionalities, but how do I pass them now? Because of the square brackets, Pebble knows that I can pass arguments to my command. How minus args. What's the service name? Assistants. What are the arguments? I want to say hello. No.
Help.
Help. Hello. Okay, there you go. Something else. Inspire me. All right, Forrest Gump. It's a good ending line. That's pretty much it. If you go for challenge C, you can find me later on if you want. Or you just make the pull request. It's a canonical chisel releases. And I'll be happy to review that and put your slides in. All right. I hope you enjoyed. Sorry for the working issues.